Greetings, friends. Randall Nagy here again with the third installment to our advanced Python technique in which we're evolving our create, read, update, and delete pattern, complete with a search and now with a list, so as to finish off the update, delete, and searching capabilities. Now, as you may recall from other lessons, we decided to put in our own reuse here so that we could create file name, because each one of our basic CRUDs operations are going to have to find a file name based upon the name of the person we have put into our database record. You also recall that we have a .json file or JSON script because we're using the JavaScript object notation. And when we create the file, of course, we're going to use create file name to get the name of the file from that script. And in like manner, when we use read, we're also going to use create file name to read the file based upon the name that the user inputs. Ultimately, of course, you can imagine that whenever we do a list, we're going to list everything in our present working directory. And if something doesn't, and with the .json file suffix, of course, we're going to ignore it. Otherwise, we're going to remove JSON from the file name so as to list the bare name, if you would, or the name tag associated with the record. So we have a real good start now of adding more information into what is becoming a file-based database in which each file has nothing more or less than a single JSON serialized dictionary. You may also note that we have created several JSON files, as we see here, and we can list them as we'll demonstrate shortly. But what I wanted to note here is that for those who have used Python dictionaries, one of the key advantages of JSON, I think, is that we do have some commonality here. In other words, we know in Python's terms that we have a dictionary and a key value listing works pretty much as you would expect. Certainly if you had any experience with programming full stack software development systems. Switching over to idle, of course, we can copy and paste our string, and running our module, we can see that without using JSON, of course, we do indeed have the ability to create a dictionary simply by cutting and pasting our data as we see here. So while there are some differences between the JavaScript object notation and, of course, the Python dictionary type, we should note that there are a lot more similarities, as well as several noteworthy differences, and a good place to begin to understand those commonalities and differences, which allow us to include different encoders and decoders, can be had by using the help system as we're demonstrating here to get more information on not only the dump, but of course the dump S capability. That will allow different encoders and a lot more capabilities that, depending upon your national language and serialization needs, may come in very handy. Note that the grand division at the serialization level is between dump and dump S, or load and load S, which will either allow us to include a file pointer as we have demonstrated, or to directly deserialize a string, no matter where it came from, a file or in our Python code, into our Python object. Our scenario is to allow ourselves or the user to select and update a record, and to simply return true if a record has been updated, otherwise to return a false. Now here's when we can start reusing things, because as you remember previously, our read operation, in addition to allowing the user to select the record to read, also returned a dictionary that we called record. So we're going to allow update to reuse our read function, and remembering that the record could be none. If we have a record, in other words, if there is something returned in record that is non-null or non-empty, we cannot allow ourselves to record whether or not the data has been changed, while the user has an opportunity to update each and every value associated with each and every key in the record read. Deciding to allow the user to simply press the Enter key and return nothing back from input besides an empty string. In a like manner, we can test if value is empty or not, and if something has been emptied into the value, of course, we know that the value is something we want to keep, and because our requirement is to know whether something has changed or not, we'll mark our changed variable as being true, and if nothing was changed, we don't have anything else to do. Otherwise, we'll get our file from our create file name routine. We can open the file so as to overwrite anything that was previously there, and then of course use JSON to overwrite the file pointer as we did with our create operation. Now, because it was a requirement, of course, once we're done dumping our file, we can easily return true, because if something went wrong, for example, if we had an exceptional condition like the hard drive failure, or somehow the permissions changed in the few moments that we had before our reading and writing, of course, JSONs.dump would indeed throw an exception. And if we get as far as line 61, of course, we know that all things work properly. Running our program, this time we could start off with a list operation to see that we have our 3 files. And interestingly, one of the curious things that would happen if we were to update our file, for example, let's take Randall and then change Randall to Nagy, and then keep everything else, of course, we would not update Randall, but because we are using the name dictionary value to create our file, we'll see that we've instead created a new file based upon the new name that we have, effectively using the update operation to clone our file. Updating Nagy once again, however, so as to change the name back to Randall, keeping the information, we can see that if we choose to read Nagy, we have the old information, but if we read Randall, of course, we can verify that we have 2 different files. And updating things deeper, we can see that we have our deeper updates changed as well. So the next scenario, of course, we want would be to delete a record. And in this case, whenever we decide to delete a record, of course, all we're doing is deleting a file. And no matter whether a file was deleted or not, of course, and in keeping with the way things are usually done in the C and C++ world, if it's been deleted, it doesn't really matter, it's not there. Otherwise, if it hasn't been deleted, once again, it's not there. So returning none is not necessarily a very informative thing to do, but it's pretty much traditional and can be expected, depending upon how much tenure and operating system level interfaces your software developers have. Once again, running upon our read operations, and if we have read something, what we're going to want to do once again is to create the file name for our name field. And because it is something we're prone to reuse later on, we should probably take a moment to confirm if the user or any other controller should allow a certain JSON file to be deleted. If so, of course, we use the OS capability to remove the file, returning none, as you might expect. The only thing to do now, of course, is to provide our should delete operation, which is pretty straightforward, given what we know, and can once again be a simple single line operation using an F string and making sure to check that only an upper or lowercase n is applied, we can return true or false based upon this simple Boolean test. Testing our application, of course, and running our code so far. We can select delete, making sure to press an uppercase so as to verify that when we list things again, of course, it has been deleted. And obviously, if we want to delete something else, typing in a lowercase will allow us to see that we weren't able to delete anything because we didn't enter in an uppercase Y. So far, so good. We verified our delete, we verified our update, we verified our create, as well as implicitly verifying many other operations. So last but not least, we have cutting and pasting my requirements from my requirements document, the scenario which will allow our user to search for a string in all records. Now, because all records, of course, comes down to all files, we have a very interesting situation here because inside of this search, we're going to display all of our results. But more importantly, because returning none isn't very informative, in this situation, we're going to return 0 on error, or if nothing was found. Otherwise, you're going to return the number of matches found, not knowing, of course, what the user has decided to look for in his or her files. So because searching is what this scenario is all about, of course, the first thing we need to do is to query the user for the input. And rather than using the term search, we'll just simply say locate, because we're going to be locating something in the file. And because no matter what we locate, we're going to be returning the count. If we have been requested to search for anything of interest, we'll reuse our file list function to return a list of our JSON files, open each file, so as to use JSON.load for the file handle. And if we have a record, or in this case, we didn't throw an exception, for each key, we can check the string associated with that key to see if the search pattern exists, keeping in mind that find will return the location of the information in the string, otherwise a -1 if nothing has been found. We're not interested in the zero-based return results, but we are interested, of course, in printing another F string in the file with our empty string, followed by the value of the record itself. Remembering to increase the count, of course. By way of review, note that whenever a string gets too long, as we see here, we can break it with the backslash. And also, we can, in a likewise manner, spread out the parameters into our functions, in this case, the print function, so as to make them fit in the recommended space as required by PEP 8. Of course, ultimately, no matter what we've done, we're going to return our count so that we can fulfill our scenario requirements as well as test our application. So the implementation of our list files function is very simple. We're going to return a list, a mutable list in this case, rather than a tuple. We're going to use the OS lister in our present working directory to see if any file that is listed in our present working directory ends with our, by now quite familiar, .json suffix. If it does not end with JSON, of course, we're going to continue to check the next file, which will repeat the logic, appending anything that does indeed contain a JSON file into our results list before returning the same. Running our application, one of the things most of our files have in common, except for the one that we changed, would be the ability to locate an @ sign. And now we see that we have our records listed, but interestingly, we have this large amount of spaces before our list, which echoes the annoying habit we have in Python to literally take all of our spaces and insert them, in this case, before our file name, keeping in mind that we did find what we want, it's just not formatted as wonderfully as we would like. A situation we can find ourselves in more often than not when we start processing complex things, of course. Another good way to reduce the real estate would be to simply create a new variable called report, in this case, where we'd do our operation, then to simply print our report in a much more succinct way. All is well. So I wanted to share this quick review and advanced topics with you, simply by way of edification and hopefully popularization of a technique that I use a lot whenever I create my user interfaces or state machines that we've talked about in Python 3000. And if you'd like to know more about either beginning, intermediate, or advanced topics, I'd invite you to go ahead and peruse and use one of my Python 1000, 2000, or 3000 training opportunities on Udemy. Thanks for watching, and I'm looking forward to seeing you in the professional software development world.